need to keep track of the variables and the number parts and know when we can combine them with multiplication or when we're combining them with addition. We have to, again, make sure that the base are the same if we're going to combine the exponents. So this base 3 can go together, this base 2, this base 2 go together. So what I'm going to do first is I'm just going to make sure that I know which ones can go with each other so I don't mix them up. So I'm going to start with the base 3. 2x, 3 to the power x times 3 to the power x means I'm multiplying by 3 double of x. Okay, so I'm going to have 2x, or we can multiply those powers together. And then I'm going to divide by 3. And keep those together like that. So those are the base 3 parts to this. I have base 2 part, and it's all connected by times. Again, we have to make sure it's all times, otherwise we're in trouble. Because we can't do add and subtract with powers. So this is going to be power to power, so 2 times x minus 1 is going to be 2x minus 2. And then same thing here, we're going to apply the power to power, so we're going to do the same thing. This is 2x plus 2. Okay, so that's where the parts came from. I'm going to do the base 3 to the power 2x, and then I'm going to divide by 3 once. Here, I'm going to multiply by base 2 2x times. I'm going to divide by base 2 2x times. Well, those are going to just cancel out, so I'm going to subtract the positive exponent with the divide exponent. Okay. I have a minus 2, so that's divide by 2 twice, and this is divide by 2 twice because it's in the denominator, so I'm going to minus 2 again. These cancel out. Okay, so these can cancel out, and then we're just left with negative 4. So I end up with 3 to the power 2x minus 1 times 2 to the power negative 4. Again, we can leave it like that, or we can rewrite it as a fraction and put this down there like that. This is good enough, this is good enough. They're both the same solution. Okay, and really, this might be slightly better to show where the divide is, but really it doesn't make too much difference. This one here, again, there's lots of things going on, so we want to simplify this as quickly and as much as we can. I don't like all the negatives because those are hard to keep track of. So instead of dividing by this fraction, it says the power negative 1 means I divide by this fraction. I'm going to multiply by the reciprocal. And as I'm multiplying by the reciprocal, I'm going to apply this power into the brackets. So I'm kind of starting to compress some steps here as I get better at this. This 3 does not get affected by that. The negative flipped the fraction, so I'm not going to change that negative. So I'm going to do power to the power with that negative. This 3 affects all the base 3 and the base y. And when I apply it to the base y, it's going to be power to power, so I'm going to multiply. Okay, so I'm going to just group the parts together that I can. So 3's go together. In the numerator, I have 3 to the power 2. In the denominator, I have 1 3, 3 3's, or 3 to the power 4. Okay, so I want to make sure I'm keeping track of that. I'm going to next go to my x's. I have x to the power 6. Divided by x to the power negative 8. Well, divide means times. Oops, that's 6a. So that's going to end up in the numerator with that. And again, I want to just highlight that so I'm keeping track of all my base x's. And then my base y's. There's power 5 and divide by y 6a times. So y to the power 5, y to the power 6a. Okay, so I haven't really done anything in this step other than just reorganize what I have. And then I'm just going to make sure I have my final answer here. So I have an extra 3 squared on the bottom. I'm going to make that x to the power 6a plus 8, since that's really divide, or multiply by x 8 times. So I'm going to add that on. Here, I think I'm going to put the y's on bottom. Now, you don't have to. Now, you could write it as 5 minus 6a, but I'm going to do 6a and then show that as a divide in the denominator. So the times by 5 is really just going to show up as divide in the denominator. Now, it doesn't matter if I put the y on top and have it 5 minus 6a, or the way I've written it here, they're both the same.